Hello, Mr. Betts here. In the video where I introduced the idea of differentiating inverse trig functions, I showed how we take the derivative of the arcsine function. I want to do the same thing with the arctangent function here. So if we want to take the derivative of the arctangent function, the first thing I'm going to do is I'm going to think of that as y equals arctangent of x. So what I'm going to do then is I'm going to solve this equation for dy dx. What I'm looking for here is what is dy dx. So to start this then, first thing I'm going to do is I'm going to write this using expressions that I know how to take the derivative of. So this equation right here, with the restrictions that we place on domain and range for the arctangent function, is going to be equivalent to the tangent of y equals x. So essentially we take the tangent of both sides of this equation and we get tangent of y equals x. Then I'm going to use implicit differentiation to take the derivative of both sides of that with respect to x. And I'm doing this with respect to x because I want to know what dy dx is. So derivative of tangent is secant squared, but I'm going to keep that y in there. And remember, with implicit differentiation, that y is the inner function, so we have to multiply by the derivative of the inner function, which is dy dx. On the right side, the derivative of x is 1, and then we solve for dy dx. So we get dy dx is equal to 1 over secant squared of y. So I'm going to use the same trick that I did with the arcsine function, and this time I'm going to use the equation here, tangent of y equals x, to build my triangle. Tangent of y means that y is the angle. Tangent is opposite over adjacent, so I'm going to call those x and 1. And then using the Pythagorean theorem, the hypotenuse is going to be the square root of 1 plus x squared. Then I want to know, I'm replacing secant of y. Remember, this is secant of y squared. So I want to know what the secant of y is. Secant is 1 over cosine. So secant of y is 1 over cosine. Remember, cosine is adjacent over hypotenuse. So this is going to be hypotenuse over adjacent. So the secant of y is going to be hypotenuse, square root of 1 plus x squared, over adjacent, which is 1. And then we want to know what secant squared of y is, so we're going to square that, and it's just going to be 1 plus x squared. So that means that dy dx, we've got this thing in the way here, which I don't want to scratch out. It's part of my work, so I'll rewrite dy dx is equal to 1 over 1 plus x squared. And again, I do this because the original problem was written in terms of x, so y in terms of x. If we had a problem where we had an implicit relation that x's and y's were mixed together, then it would be okay to leave y in here. But since we have an explicit function strictly in terms of x, then our answer should also strictly be in terms of x.